Hello everyone, welcome to Extramarks live classes. In this session today, we are going to discuss about one more concept under the heading of interconversion of states of matter. Yes, today we are going to talk about evaporation and all the related concepts like the factors that affect the evaporation. We'll understand each and every factor in detail and we'll discuss how it affects and why it affects the rate of evaporation. In addition to this, before we discuss about the factors affecting the evaporation, we will understand what evaporation actually is. We'll talk about the differences in between evaporation and boiling, and we'll understand why evaporation is known as a surface phenomena and why evaporation of any liquid from any surface results in cooling effect being produced on that surface or in the surroundings. And towards the end of the session, we'll have a look at various day-to-day life examples and observations that can be answered through the understanding of cooling effect produced by evaporation. Okay, so let's begin the session with evaporation. Let's begin with understanding what is meant by evaporation. Process of conversion of a liquid into its gaseous state, into its vapor state at any temperature below boiling point of that liquid is known as evaporation. Now, what does this mean? See here, when we discuss evaporation, it is very important to compare it with boiling. Because in boiling also a liquid converts to its gaseous state, isn't it? So in both the things, in evaporation as well as in boiling, in both the processes, what is happening? Liquid is getting converted to its gaseous state. So it is very important to understand how these two processes are different from each other. See, when we studied about boiling, I told you about boiling point. What is boiling point? Boiling point is the minimum temperature up to which a liquid needs to be heated before it starts boiling. But no such temperature, no such heating is required for evaporation to take place. That means boiling is a temperature dependent phenomena. A liquid boils only at a specific temperature or temperatures above that specific temperature known as boiling point. So if we want to boil a liquid, we need to provide it heat, we need to put in some efforts. Boiling cannot take place on its own at room temperature. So for any liquid whose boiling point is quite high, what we need to do is we need to provide heat energy, we need to heat the liquid up to a specific temperature, then only boiling takes place. That means boiling is a temperature dependent phenomena. But when it comes to evaporation, no such external heating is required. Whatever is the room temperature, at that temperature, what will happen? The process of evaporation will start. Okay, the process of evaporation will take place. It will keep on happening. So, evaporation is a temperature independent process. It can take place at any temperature. Just one requirement is there, that the temperature should be below the boiling point of the liquid, because if the temperature reaches up to the boiling point of the liquid, the process will not be labeled as evaporation. In that case, we will call that the liquid is boiling, because at that specific temperature, the liquid will actually start boiling. Okay, so evaporation is nothing but the conversion. It is a name given to the process of conversion of a liquid into its gaseous state, its vapor state at any temperature below the boiling point of the liquid. The second point about evaporation is that it is a surface phenomena. What does this mean? This means that the particles which are present at the surface of any liquid will only participate in the process of evaporation, and the particles which are present in bulk of the liquid will not participate. Let's try to understand this with the help of one example. Suppose I have a beaker here, and inside this beaker I have filled water. So suppose these are the molecules of water. Okay. Since water is a liquid, there is a little space present in between its molecules. Now, the molecules inside water can be categorized into two types. The molecules which I am highlighting are present at the surface of the water. They are in direct contact with the external atmosphere. So, I will label these particles as surface particles. Okay. And these particles which are not exposed to the external environment, which are present in the bulk of the liquid, will be labeled as bulk particles. My dear students, in the process of evaporation, what will participate? Only the particles which are present at the surface of the liquid will participate, and the particles which are present in the bulk will not participate. And this is the reason why we label evaporation as a surface phenomena, because the particles which are present at the surface will only participate in the process of evaporation, and the particles present in the bulk will not participate. Evaporation results in cooling. This is one more thing. Evaporation, whenever evaporation takes place from any surface in any area, it results in cooling effect being produced in that area or on that surface. We will understand in detail why and how does this cooling occurs, but before that, let's compile the differences in between evaporation and boiling that we have already understood, but yes, let's quickly revise them once more and then we'll move to the cooling effects of evaporation. So, evaporation takes place on its own. At all the temperatures, we need not to put any kind of efforts. We need not to intentionally heat the liquid to evaporate it. It will evaporate on its own at room temperature only, absorbing the heat energy from the surrounding air or from the surface on which the liquid is kept. On the other hand, boiling takes place only at a specific temperature, and we need to heat the liquid, we need to increase the temperature up to that value, then only boiling will start. Evaporation is a surface phenomena. That means it takes place only from the surface of the liquid. Only the particles which are present on the surface of the liquid will participate in evaporation, and the particles which are present in bulk will not participate. Such particles which are present in bulk of the liquid participates in the process of boiling. So, boiling involves all the particles, be it surface particles or bulk particles, all the particles will take part in the process of boiling. And evaporation causes cooling, but no such cooling effect is produced when boiling takes place. So, evaporation results in cooling effect, but boiling does not produce any cooling effect. So, how does cooling occur? What is the reason behind cooling? See, during evaporation, what happens? Whenever a substance is evaporating, see, suppose this liquid needs to evaporate. Okay, this is water kept in a liquid, or let's take example of lake. Suppose there is a lake here. In this lake, water is present. Now, the particles which are present at the surface, they want to move out of this liquid. They want to convert to the vapor state and evaporate. For conversion of any substance from liquid state to gaseous state, what is needed? Increase in kinetic energy is needed. When we were discussing about the properties of different states of matter, what we studied? We studied that the amount of kinetic energy possessed by particles in the gaseous state is more than the kinetic energy possessed by particles in the liquid state. That means when particle needs to move from liquid state to gaseous state, kinetic energy needs to be increased. To increase kinetic energy, these particles need heat energy. So, the particles, they absorb heat energy from the surrounding air, from the bulk of the liquid, and what happens? The heat moves in. Isn't it? The heat energy from the surrounding air will move in. These particles will absorb heat. They will utilize the absorbed heat energy in increasing the kinetic energy, as a result of which the overall heat content of the surrounding air will go on a lower side. It will decrease. That will result in decrease in temperature. Let's take one more example. Suppose water is evaporating from my skin. I wash my hands. You can even try doing this. You can simply wash your face or wash your hands and leave them as it is. Please do not wipe your face and hands and go and sit on a chair under a fan, or simply go and sit on a chair. Even if you do not switch on the fan, that is okay. After some time, what will happen? You will start feeling some like a cooling effect on your skin. The skin of hands and face that you washed will feel a little cool. Why? What happens? The water particles which are evaporating from my skin. Suppose water is evaporating from my hand. So the water particles need some heat energy to increase their kinetic energy. From where will they get the heat energy? They will absorb the heat energy from my skin as well as from the surrounding air, as a result of which the overall heat content and thus temperature of my skin will go on a lower side, producing a cooling effect on my skin. Similarly, when you wash your face and you leave it as it is, what happens? The water particles from your face, they evaporate. While evaporating, they absorb heat from your skin and produce a cooling effect on your skin. So, what happens during evaporation? The molecules of liquid, in order to increase the kinetic energy, absorb heat from the surrounding atmosphere. As a result, they overcome the attractive forces. We know that some kind of attractive forces exist in between the particles in liquid state as well. In gaseous state as well, the attractive forces are there, but the strength of attractive forces is more in liquid as compared to in gaseous state. So when the particles want to break free from each other, they need to overcome the attractive forces, and to overcome the attractive forces, kinetic energy needs to be increased, and to increase the kinetic energy, heat energy is required. So this is the cascade. So by absorbing the heat energy from the skin, from the surrounding air, the water particles or the particles of any other liquid, they increase their kinetic energy that helps them to overcome the attractive forces and convert into vapors. And as a result of all this, the surface from where evaporation is taking place, the area in which evaporation is taking place, its temperature decreases and a cooling effect is produced in that area or say on that surface. So this is how evaporation leads to cooling. Now, coming on to the factors that affect the rate of evaporation. And what are those factors? The factors are temperature, surface area, humidity and wind speed. These are the four factors which change the speed at which evaporation takes place. So, we are going to discuss about these factors one by one. Let's start our discussion with surface area, and let's try to understand how does change in surface area affect the rate of evaporation. So, first of all, you need to know the fact. The fact is, greater the surface area, more is the rate of evaporation. That means with the increase in surface area, the speed at which evaporation takes place increases. Now, why does this happen? Just now we have understood that evaporation is a surface phenomena. That means the particles which are present at the surface of the liquid will only participate in the process of evaporation. With the increase in surface area, more number of particles get exposed to the external environment, and hence more number of particles take part in the process of evaporation, increasing the overall speed at which, overall rate at which evaporation is taking place. Have a look at these two examples here. This is the first case and this is the second case. In first case, only these many particles, around 10 particles are exposed to the external environment because surface is less. So, less number of particles are present on the surface and less number of particles will take part in the process of evaporation. But in the second case, what is happening? Since the container is broad, since the area of the surface is more number of particles, more than 20 particles are now present at the surface, and these particles will all take part in the process of evaporation. So, in the first case, at one instance, at a time, only around 10 particles are able to take part in the process of evaporation. But in the second case, due to increase in the surface area, now more number of particles are exposed to the external environment, and hence almost double or say more than double particles as compared to first case will take part in the process of evaporation at one time. So obviously in second case the process of evaporation will speed up because the number of particles which are taking part in the process of evaporation are now increased. And why this has happened? This has happened because of increase in surface area. isn't it? There is one more day-to-day life example which we can use to understand this. Whenever we wash our clothes, what we do? We spread them wide out, isn't it? We spread them on strings. Why do we do that? Why don't we fold our clothes and keep in almirah and allow them dry over there only? Not possible. You all will say, what kind of thing is this, ma'am? The clothes will not dry for days if we keep them wet in the almirah. Why? When we spread the clothes, we are making more surface area available for the evaporation. When we fold the clothes, only the top layer, the bottom layer and the sides will allow the evaporation. But when we spread out the clothes, all the evaporation will take place from all over the cloth, and hence the evaporation will speed up. So, because of increase in the number of particles that can take part in the process of evaporation, the speed increases with increase in surface area. So, what we can conclude here is, we can say that surface area is directly proportional to rate of evaporation. What is meant when we say it is directly proportional? We mean that with the increase in surface area, the rate of evaporation will also increase. Let's move to the next factor now. The next factor is temperature. What is temperature? Temperature is defined. You can describe temperature as degree of hotness or coolness of any body or any area. Okay, so it gives you an idea on how much cold or hot a area or a object actually is. So, with the increase in temperature, what happens? With the increase in temperature, more heat is available for the liquid particles to absorb, and they will be able to increase their kinetic energy quickly. So, with the increase in temperature, the rate of evaporation also increases, and this happens because with the increase in temperature, the kinetic energy of the particles also increases. Since more heat energy is available in the surroundings, the particles are able to absorb heat quickly and their kinetic energy also increases quickly. So, the particles are able to overcome the forces of attraction from the neighboring particles easily and get converted to vapor state quickly. That is the reason why our clothes dry quickly in the summer season, isn't it? Why water evaporates quickly in the summer season as compared to winter season? The reason is temperature. With the increase in temperature, overall rate at which kinetic energy increases and the speed at which the attractive forces are overcome increase, and hence increasing the rate of evaporation, increasing the speed at which evaporation takes place. So, again you can say that temperature is directly proportional to rate of evaporation. That means with the increase in temperature, the speed at which evaporation takes place will also increase. The next factor is humidity. Humidity is described as the amount of water vapors present in air around us. You must have heard this word, especially when we talk about coastal regions. When we talk about Mumbai, when we talk about Chennai, we say that the humidity in these areas is quite high. What is meant by that humidity? It is nothing but the amount of water vapor which is present in air in any area. So, whenever you have a look at the humidity value of any area, what you should understand? You should understand that yes, this much amount of water vapor is present in the surrounding air. And what happens to evaporation with the increase in humidity? With the increase in humidity, the rate of evaporation decreases. Yes, this is a factor which is actually inversely proportional to the rate of evaporation. With the increase in humidity, the speed at which evaporation takes place decreases. Why does this happen? Let's try to understand this with the help of one example here. Have a look at these two images here. This is the first case and this is the second case. In first case, the humidity is 95% and in the second case the humidity is 10%. Okay, see, before we start this discussion, you should know one thing. Air does not have unlimited capacity to hold water vapors. Air is also having a limited capacity to hold water vapors. After a limit, the air will not be able to allow more water vapors to move into it. Okay, so please remember that air is also having a limited capacity to hold water vapors. So, whenever humidity is high, what does that mean? This means that the amount of water vapor in the air is already high. When I say the humidity is around 95%, that means 95% space available is already saturated with the water vapors, only 5% space is empty. But when I say the humidity is 10%, that means only 10% water vapors are accommodated till now and a lot of space is still available for more water vapors to be accommodated. So whenever humidity is high, the amount of water vapors, these black circles here represent water vapors. So the amount of water vapors in the air is already high. So if water wants to evaporate from this lake, the speed at which water vapors will move into the air will be slow, because the concentration, the amount of water vapors here in the air is already high. So the speed at which new water vapors enter this air decreases. On the other hand, when the amount of humidity, amount of water vapors, that means overall humidity is less, the water vapors from this lake will be able to enter the surrounding air easily as well as quickly. So in second case, the evaporation will be faster and in first case, the evaporation will be slower. So what you conclude from here? We can conclude that humidity is inversely proportional to rate of evaporation. The speed at which evaporation takes place, it decreases with increase in amount of water vapor in the surrounding air, because the air is having only a limited capacity to hold water vapors, and if the water vapors are already present in high concentration in air, it becomes difficult for the more water vapors to enter inside it. But whenever the amount of water vapors is less, the evaporation is easy and fast. So this is how humidity is related to speed at which evaporation takes place. The next factor here is wind speed. Wind speed means the speed at which air blows, air breeze, the speed of the breeze of the air. So with the increase in wind speed, what happens? Have a look at these two diagrams here again. Case 1 and case 2. See, what happens? Suppose this is a string on which a cloth is drying. Okay, suppose this is the cloth. Water needs to evaporate from the surface of this cloth. Okay, so water will evaporate from the surface of the cloth. And the water vapors will accumulate in the surrounding air. Okay, slowly as the drying process will progress, drying will keep on happening, the water vapor will keep accumulating in this area. Now, what if wind blows from this direction to this direction? When wind blows from one direction to other direction, the wind will take away these water vapors along with itself. And the air around this cloth will again be empty. Isn't it? Since, because of continuous evaporation taking place from this cloth, the water vapors get accumulated. That means the overall amount of water vapor in the surrounding air keep on increasing, which results in slowing of the further evaporation of water from the cloth surface. So if wind passes from here at a high speed, it takes away the water vapors along with it, and the air, surrounding air, or say the saturated air, is replaced with the unsaturated air. Okay, so air moves, along with that water vapors also move, and the saturated air is replaced with the unsaturated air, and again the evaporation speeds up. And that is the reason why we observe that clothes dry at a faster rate when wind blows continuously. Isn't it? Whenever we want to dry our clothes in the rainy season, what we do? We bring them inside our room, we spread them on chairs and we switch on the fan. Why we do that? We are increasing the wind speed, and that increases the rate of evaporation. So, with the increase in wind speed, the rate of evaporation also increases. And why does this happen? This happens because the particles of water move away with the wind, thereby decreasing the amount of water vapor in the surrounding air and hence increasing the speed of evaporation. So again, wind speed is directly proportional to the rate of evaporation. With the increase in wind speed, the speed at which evaporation takes place also increases. And I hope the reason is also clear to you. So what are the 4 factors that affect the rate of evaporation? First is surface area, second is temperature, third is humidity, and fourth is wind speed. Out of these 4 factors, surface area, temperature, and wind speed are the factors which are directly proportional to the rate of evaporation. That means with the increase in surface area, with the increase in temperature, and with the increase in wind speed, the speed of evaporation, the rate at which evaporation takes place, will also increase. There is only one factor which is inversely proportional, and that is humidity. With the increase in humidity, the rate of evaporation decreases. So please remember this relationship as well as the reason why evaporation is increasing with increase in temperature or why evaporation is decreasing with increase in humidity. The reasons should also be clear to you all, because a number of questions come from this particular section. Understanding based questions, reasoning based questions are asked. Now let's have a look at a few daily life examples. A number of examples where the cooling effect of evaporation is made use of for our benefit, or a few observations where the answer to the observation is cooling effect of evaporation. Okay, so the first is clothes dry faster on a hot sunny day. Why? What is the reason behind this? You will be able to answer this question, this particular observation. You can present an explanation to this based on the factors affecting evaporation, isn't it? Temperature is one of the factors which affects evaporation, and with the increase in temperature, evaporation increases. This is what we just now studied. So on a hot sunny day, what do you expect? Do you expect temperature to be on a lower side or on a higher side? Obviously, on hot sunny day in summer season, the temperature remains at a higher side, and that is the reason why our clothes dry faster in summer season on a hot sunny day, because temperature is high, and with the increase in temperature, the speed at which evaporation takes place also increases. So water from our clothes also increases at a faster rate. So when you want your clothes to dry quickly, spread them out. By spreading them out, you are increasing the surface area for evaporation, and try to spread them out under sun. Okay, in open where sunlight is coming. So 2 factors will be combined, and both the factors will contribute to increase the evaporation, and your clothes will dry quickly. Okay, let's have a look at another example. You must have seen people, especially in villages, in cities also, people, they sprinkle water in front of their shops, on the rooftops, or on the open grounds. Why? What is the benefit of doing this? This particular observation or say action can be explained, an explanation can be presented using the explanation or say understanding about cooling effect of evaporation. We have understood that whenever evaporation takes place, the cooling effect, a cooling effect is produced in the surroundings as well as on the surface from which evaporation takes place. Now, when this man is sprinkling water on the ground, what will happen? The water from the ground will evaporate, and while evaporating, the water will take away a huge amount of heat from that surface, producing an overall cooling effect on that surface, and it will be comfortable for people to walk on that, and they will feel comfortable overall. So, we and other people also, they sprinkle water in open grounds or on the rooftop in summers especially, because water evaporates. When water evaporates, it takes away huge amount of heat along with it and producing a cooling effect, making it comfortable for people to live over there. One more thing, one more day-to-day life example. Whenever we use nail paint remover, we suddenly feel cooling effect. If it falls on our palm feels cool. Whenever that nail paint remover in the cotton touches our skin on the fingers, we feel sudden cooling. Why does this happen? This happens because nail paint remover, nail polish remover contains a chemical substance known as acetone. Acetone is highly volatile, its boiling point is very less, and hence it evaporates quickly. As soon as particles of acetone comes in contact of our skin, they start evaporating, and while evaporating they take away heat energy from our skin, because for evaporation acetone particles will also need some heat energy. From where will they get that heat energy? They are in direct contact of our skin and they will quickly absorb heat from our skin, will convert to the vapor state, and our skin will feel cool. So this is the reason why on pouring the nail paint remover, our palm, the skin of our fingers feel cool, because the acetone while evaporating takes away heat from our palm, from the skin of our fingers. Okay, let's have a look at one more example. This is again a very, very important example, and a number of questions are asked from this particular concept and understanding. Water kept in earthen pots become cool or say cold, but the water which is kept in the steel pots does not become cool. What is the reason? The same water when kept in earthen pot after some time becomes cool and it is very pleasant when we drink it. But the same water when we store it in a steel container, in a steel pot, does not become cold. Why? Why does this happen? My dear students, the earthen pots that we use, they are porous in nature. Porous means they have small holes on their surface which allows the air to pass through it. So air circulation is continuously maintained across the earthen pots. Air from both the sides is allowed to move across the earthen pots. So when the water is stored in the earthen pot, what must be happening there? Please imagine at the molecular level what must be happening. Suppose this is the water filled in the earthen pot. The particles which are present on the surface will definitely evaporate, and the water vapors will get accumulated here in the empty space above water level. Okay, when wind blows, when air passes through it, what happens? The water vapors are moved away and the air here again becomes empty to accommodate more water vapors. So this is, in this way, evaporation continuously takes place inside the earthen pot. But nothing such happens inside the steel pot. So due to continuous evaporation of water inside the earthen pot, the remaining water, the water in the bulk becomes cool, because these particles on the surface will take away the heat of the particles in the bulk, making them cooler. So this is how water when stored in the earthen pots become cool, and when we store water in these steel pots, it does not allow continuous evaporation. The air is not replaced because there are no pores, no holes, and air circulation is not maintained. Okay, very important example. A lot of questions are asked on this, so please remember. Again, why should we wear cotton clothes in summer? What is the reason? My dear students, cotton clothes are good absorbers of water. Our sweat contains a lot of water and hence cotton clothes can absorb our sweat very easily. So, if this is our skin and our skin is producing sweat, so sweat will be here on the surface of our skin, and this sweat is very, very troublesome and irritating for us, especially in the summer seasons. So, what we will want? We would want this sweat to evaporate and make our skin feel cool. When we wear cotton clothes, what happens? Suppose this is the layer of the cloth which is made up of cotton. Cotton being a good absorber of sweat, what it will do? It will absorb the sweat particles. It will absorb sweat and it will expose the sweat to the external environment for evaporation. So this is how cotton clothes absorb the sweat from our skin and expose it to the external environment for evaporation, speeding up the evaporation of our sweat, making our skin feel cool. Along with this, cotton clothes are porous. They allow the air to circulate. They allow the air to pass through them. And hence, again, the evaporation of sweat speeds up due to circulation of air. So, cotton clothes make us feel comfortable in two different ways. First is, because of their porous nature, they allow the air to pass through it. So, continuous air circulation is maintained, as well as they are good absorbers of our sweat and introduce the sweat, absorbed sweat to the environment for evaporation. And this is how cotton clothes make us feel comfortable. In place of cotton cloth, if you wear silk cloth, all this will not take place, because silk cloths do not have pores. They do not allow air circulation, as well as they are not good absorbers of water, and hence they will not absorb sweat. Sweat will start accumulating under the, like in between the skin and the cloth, and you will not feel comfortable. That is why it is advisable to wear cotton clothes in summer season, and we should preferably wear silk clothes or any such cloth which does not allow much air circulation in the winter season. Okay, so selection of cloth is also very crucial if we want to feel comfortable, and scientific reasons are there behind their selection. Similarly, we feel cool after performing vigorous exercise. Why? While exercising, our body produces sweat, and that sweat evaporates from our skin, making us feel cool. Okay? Why doctors spray or say apply alcohol or ether on our skin before injecting any medicine? See, alcohol or ether, whatever is used by doctors, they are again highly volatile substances. They evaporate very easily. So, as soon as doctor rubs alcohol or ether on our skin, those particles of alcohol and or ether, they start evaporating from our skin and producing a cooling effect on the skin. The temperature of the skin is decreased, producing some kind of numbness over there. So, we do not feel the pricking that much. The pain is overall reduced. So, the cooling effect of evaporation is made use for our benefit in this particular case, isn't it? Similarly, other processes can also be used. The other concepts of interconversion of states of matter can also be used to explain some day-to-day life examples. See, you must have seen that the water droplets get deposited on outer surface of any glass in which cold drink is kept or cold water is kept. Why does this happen? This happens because water vapors which are present in the air, they condense. They get condensed on coming in contact with the cold surface. So, explanation to this particular observation is not evaporation. Explanation to this particular observation is condensation of the water vapors which are present in the surrounding air. As soon as these water vapors come in contact with the cold surface, they condense and get deposited over there. And that is the reason we are able to see small water droplets on the surface of glass. Similarly, perspiration keeps our body cold. Why? How? So, perspiration is nothing but vigorous sweating. Especially in the summer seasons or when we do vigorous exercise, our body perspires a lot. That means it produces a lot of sweat. And that is a mechanism of the body to maintain its own temperature. The sweat will evaporate from the skin, producing the overall cooling effect and maintain the body temperature. So, all these were the day-to-day life observations and applications of cooling effect of evaporation, as well as several explanations can be made if we understand the effect of various factors on the process of evaporation. Now, please use your understanding from today's session to answer all these questions. All these questions goes as homework for every one of you. And I'm pretty sure that you all will be able to write answer to all these questions. Now, let's quickly recap what we studied and discussed today. In today's session, we discussed completely about evaporation. We understood what evaporation is. We understood how evaporation is different from boiling. We discussed and understood about the various factors which affect the rate of evaporation. And we understood why evaporation produces a cooling effect and how that cooling effect can be made use in our day-to-day life, or how the understanding about cooling effect of evaporation can be used to give explanation to several observations that we make in our day-to-day life. So I hope every one of you properly understood everything in today's session. That is all from my side. Thank you.